Okay, so I wanted to show you how to do a t-test using data. This is an example of one of the problems in your book. So we're looking at a sample where people watch 2.49 hours of television per day, sample size of 15 people. We're given the data over here to the right, and we want to know if the average person watched a different amount. So this is a two-tailed test. So because it's not greater than, it's not less than, it's either greater than or less than. So as usual for the null hypothesis, it has an equal sign, so that would be 2.49. For a two-tailed test, it's not equal to, because we have to include both greater than and less than, and it's certainly not equal to. So not equal to 2.49. So we can get that right there. I will check my answer. Okay, great. Now I will open Statcrunch by using the icon to the right of the data set that is there. My data set is open in Statcrunch, and now I can go to Stat, T-Stats, one sample with data. I'm picking variable 1, it's called. I could change the name of that variable if I want to. I can see my hypothesis test over here to the left. It's equal to 2.49 or not equal to 2.49. The critical significance level is 1%. So I'm going to show my critical value here as 0.01 and hit compute. Okay, so now it wants to know what the test statistic is, which is given right here, and round it to 2 decimal places. So it's 3.51. And we got that one. So let me pull my Statcrunch back up. And now it wants to know the critical values for T. So because this is a two-tailed test, we're using the not equal sign, could be greater than or less than. I know that it will be C. And once again, let me go back here. My critical T is given as 2.9768. It says to round to 3 decimal places. So my critical T is given right here as 2.9768, 2.977. I type in 2.977 here, and voila. So now I need to compare my critical T to my test statistic. This is much like the Z value. So if the critical value is between if the T statistic is between the critical values, then I would not reject the null hypothesis that people watched on average 2.49 hours of television per day, because it would be between those two areas. So if I do this, and I use my T here, and it is a critical level of significance level of 0.01, so this is this area right here is half of 0.01, the same as here. So this is alpha equals 0.01 divided by 2, which is 0.005. And you don't need that for this particular question, but if you're looking for the p-test, that would be important. Okay, so my critical values are 2.977. So this is 2.977, and this one is minus 2.977. My test statistic is 3.51, which is to the right of the critical value. So it's not contained in this part of the distribution, the t-distribution between the critical values. Remember, the mean would be right here, the mean that we are testing, 2.49. So if it were to fall in this area, we would not be able to reject the null hypothesis. But because it's beyond the critical value, we do reject the null hypothesis. And the way you state this is reject the null hypothesis. The data provide sufficient evidence to conclude that the amount of television watched by the average person is different from the value reported in the study. Okay, yay, we got it. So that one's all done.